Good morning, everyone. In today's class, we'll just discuss the lasers. What is actually the meaning of lasers, and what are the principle on which the laser works, and what are the different types of lasers we'll discuss in today's class. And also at the end, we'll just see some videos to help you understand more clearly about the laser. So we'll just start with the laser. Actually, the laser is an acronym which stands for light amplification by the stimulated emission of radiation. So with this starting few words, we just start with the important characteristics of the lasers. Lasers are having a special characteristic with respect to the normal light, which is non-monochromatic source of light. So laser light is a highly monochromatic and highly coherent, and also it exhibits a special property of high intensity and high directionality. So the basic principle on which the laser light works is stimulated emission, which is postulated by Einstein in the year 1970. Right. So with this, we just this 1970. You can just see this 1970 is the year in which the stimulated emission has been postulated by the Einstein. Right. As we move on to the next important slide, that is deals with the different types of laser and their discoveries. 1916, the year 1960, the solid state laser, that is a ruby laser, was developed by the scientist called Myman on the principle of stimulated emission. So you can just see this is the scientist who has discovered the solid state ruby laser, the first laser which has been discovered by the scientist Myman. In the year 1961, the gas laser was discovered, that is helium neon laser, was developed by Ali Javan and a few others in Bell Telephone Laboratory. Now, these are the two important types of laser that we are going to discuss in today's class, and also we'll deal with the semiconductor laser. So with this starting end, we'll just go for the principle of laser. What is actually the meaning of the absorption and the emission? And these emissions are two types of emissions, that are spontaneous and the stimulated emission. So whenever a light is reacting with the matter, so the two processes may take place, that is either the absorption or the emission. You can first discuss about the absorption. When we just discuss about the absorption, we just say that let us consider two energy levels in which the atoms are residing at the ground state. You can just see that four spheres, right? In the first 10, four spheres, that is the shape of the atoms which are in the ground state. And when you give some external source, that is the light, when a light radiation is interacting with the atoms which are in the ground state, you can just see that it is in the wave form. So when they are reacting with the atoms which are in the ground state, the atoms are excited to the higher energy level. You can just see this, the atom has excited. So by observing the radiation, the atom has moved to the excited state. So that particular process, actually we say that absorption, and this absorption, we say that this is actually stimulated absorption, or we say induced absorption, right? When we go to the next part, that what is happening when we know that the atom is in the excited state. So now it will not stay for much time in the excited state, so it will try to come back to its ground state. So how it will come back to the ground state? By there will be two processes, two methods, right? So one method is that while coming to the ground state, it will emit the radiation by itself, and we say that emission of the radiation is nothing but spontaneous emission, and this type of emission is possible in the normal light. So what is happening actually to the laser light is that when the atom is in the excited state, you can just see this is the atom which is in the excited state. When we induce some external source, again a photon has been induced, right? When the atom is coming to its ground state in the air, right? You can just see that it will absorb one of the photon and it will emit the radiation. That radiation is nothing but, we say that is the laser radiation, and this type of emission, we say that is called stimulated emission. I think that you got a very clear idea regarding the stimulated emission, and this process of stimulated emission is actually takes place in the laser, right? This is the basic principle on which the laser works, right? So now as we move to the next one, see, you can just see that the sentences with the sentences, what is actually the stimulated absorption of radiation. So we just discussed in the last slide the process of exciting the atom to the highest energy state, or we say higher energy level, by observing stimulated incident photon. We say that is called stimulated absorption of the radiation, right? So again, we just say that this process is known as stimulated absorption or induced absorption, right? When you go to the next one, so what we discuss in the next slide as we move, that since the atom in the excited state, so now the atom will try to come back to its original state, that is ground state, that is even, so it will emit the radiation without any external source. And with this type of emission of the radiation, we say that is spontaneous absorption. So as the excited atom will stimulate by some external photon, you can just see that there is incident radiation, the atom in the excited state, and try to come back to its ground state. So while coming back to its ground state, another photon will be induced, and now the emission of radiation will have the energy 2h nu. Now, as we move to the next important aspect, now this particular aspect we have just discussed in the previous slides. Now, what are the different types of lasers that we see, and what is there in our syllabus? See, in our we are discussing, right? First, now we are going to discuss about the different kinds of lasers here. So the different kinds of lasers are solid lasers, gaseous laser, liquid lasers, and the dye lasers and semiconductor lasers. But in the syllabus, we are having a solid state laser. We have to discuss solid laser, gaseous laser, and in that gaseous laser also we are dealing with helium neon laser, and also we'll discuss the semiconductor laser. Now, in the next phenomena, what we are going to do is that we just see the schematic diagram of the solid state laser, that is the ruby laser, right? You can just see that when we see the diagram very closely, you observe that what are the components which are there inside the uh, ruby laser. So in order to produce a ruby laser or a solid state laser, you can just see that we are having a power supply. With this, we will ignite, right? We'll pump the atoms. So there is a switch here. With this, we'll just we'll start giving the power supply to the, what you can say, the quartz flash tube. You can see there is a helical shape cross what you can say, quartz flash tube, and here you are having a polished aluminum reflecting cylinder, and we'll have two types of mirrors here. One, the left hand side, you have 100 reflective mirror, 100% reflective mirror. On the left hand side, there is a what you can say, partially 95% reflective mirror, through which the laser beam will be emitted. You can just see that the color of that cylindrical rod, right? So it actually consisting of aluminum oxide, right? It was a combination of aluminum oxide, right? So now we just discussed about the video, and also we say that this is actually the ruby crystal, right? So as we move to the next slide, you can just see that what is actually happening in the construction part. So ruby laser is consisting of aluminum oxide with a chromium oxides have been doped with a percentage of 0.05. Now, one end of a rod, that ruby rod, is fully silvered and polished. That is completely polished and 100% reflective side, and the other part is partially silvered reflecting part, and which is known as optical resonator. The rod is surrounded by a glass tube. You can just see in the figure also, the rod is surrounded by glass tube, which is also surrounded by the helical flash lamp. You can see this glass is surrounded by helical. You can just say the shape of that particular flash lamp is in the shape of helical. So we just say that is called helical flash lamp. With this, uh, yeah, this is the helical flash lamp. You can just see this particular part as a, we say that that is a helical flash lamp. Right now, when we move to the important part of working, so here you can just see that you are, first of all, you are having ground state and the higher energy state. The ground state and higher energy state, in between that, you are having a metastable state. You can just see that there is a metastable state. So when a flash lamp light will be flashed, right, on the ruby rod, the chromium ions, which has been doped in the aluminum oxide, will excite to the higher energy state, and the chromium ions will be will be staying in the higher energy state for some time, and that is about 10⁻⁻8 seconds, and then slowly that ions will be transmitted to the metastable state. The metastable state is actually lying between the ground state and the, you can just see this is the metastable state, where it is lying between the ground state and the higher energy state. So the laser radiation which is coming from the higher energy state, when it is coming to the from the metastable state to the ground state, some amount of radiation will be emitted, and the wavelength of that radiation is found to be 694.3 nanometer, or we say that is called 6943 angstrom, and the emission is nothing but it is a pulsed one. It is not a continuous laser, that whatever the laser beam will be emitted, that is a pulsed form, right? So you can just see this about the ruby laser, and what is actually the gaseous laser. Yeah. Yes, we just see the video of how this ruby laser is made up of. You can just see within a few glass envelope complete, which shows the helium neon laser mixture. So this is a glass envelope, and you are having a helium neon mixture, and helium neon mixture is actually 10 parts of the helium is taken, and 1 part of the neon is taken inside a discharge tube, right? This helium is 10 part, and your neon is 1 part, and which is taken in a discharge tube. So what is happening here is that we are having another important aspect that we are having. We are having at the left hand side cathode, and you are having an anode, right? You can just see the cathode is there and anode is there, and the one end is left hand side. You can just see this. We say that high reflector on the right hand side, and the left hand side output coupler. This is a partially silvered one from which the laser beam is coming out. From this end, the laser will come out, that is output coupler, and there is a left hand, right hand side. You find that there is a highly reflected, that 100% reflecting surface, right? So now what is happening actually? We just see this in the construction and working of the helium neon. You can just see this helium neon laser actually consisting of large and narrow discharge tube in the ratio of 10:1. The tube is enclosed with fully partially reflecting mirrors, which serves as an optical resonator, or we say that it's called optical act cavity. And this, with this, radiations are entering into the tube, and these radiations are nothing but they are the completely polarized radiations. Now, what is actually happening? How this laser beam is produced in the case of helium and neon. So we can just see this. There is a figure of helium and neon. So these two QS and 1S0. So what it actually means that whenever we are giving some amount of power to the helium and neon, the helium atom is getting excited, and it will excite to the higher energy level. And we know that there is neon ions are also available. So neon ions are also excited, and these helium ions are not directly take part in the laser transition, but they will excite the neon atoms. They will collide with the neon atoms. So as they are colliding with the neon atoms, they are excited to the higher energy levels. You can see this helium neon laser transition is a 4-level energy system. So the population of these levels is, you can just see that we find that more number of atoms will be residing the higher energy level when compared to the ground state. So there are non-radiative transition which is taking place here. You can just see this is 3.39 micrometer, and some of the atoms will be traveling in this particular energy level, and this is called the radiative transition, which is having a wavelength of 632.98 nanometer, or we just say that 6,328 angstrom, right? And few atoms will be non-radiative transition will take place, that is infrared transition. Now with this we can know that how this helium neon laser is emitting a very high red color continuous light beam, laser light beam. So now what are the different applications of the lasers? You can just see that we are having more applications in the communication system, in optical fiber communication system. Also we had a drastic due to its drastic applications, due to its large bandwidth, more channels can be simultaneously transmitted. You can just see this schematic diagram. And in the industries also we can use this lasers to blast holes in diamonds and hard steels, and they can also use to cut and drill weld, remove the metals from the surfaces and so on. So now you can see this in medical sciences. We can use the carbon dioxide and argon lasers to treat the liver and lung diseases, and the laser surgeries are uses to the use to just remove the tumors which are present in the spinal and the brain. So particularly in the spinal and brain tumors, we can, by using the carbon dioxide laser, we can just remove that tumors, right? Kidney stones can also be what you can say can be smashed with the help of the laser, and lasers are used in the eye treatment also. You can just see this, how this laser light can be used to detach this what you can say it will act as a, you can see this laser can also repair a detached retina which has been broken, the loose form, right, here part of the eyeball. And the laser is very useful in removing the extraneous blood vessels that it can form. You can see that extraneous blood vessel in the, which is exactly above the eyeball. So with the help of the laser beam, we can just remove this what you can say extraneous blood vessel. So now this is the very important. You can see this. This can be removed by using the laser light, right? With this few applications, right, we again see how the semiconductor laser is actually working on. So the last one of our syllabus, that is semiconductor laser. So we just see that how this semiconductor laser can be formed. And also we are having application of laser in military. Also this laser beam can be used to know exactly target the enemy airplane, and the laser can serve as a war weapon also. High energy lasers are being employed to destroy the enemy aircrafts and missiles, right? So this is one of the applications of laser. Laser also used to cut glasses, drill holes in the ceramics, right? We just discussed in the class today. In the previous slides we have shown you. So now we just see the video. We just see the video of semiconductor laser. And with this, we'll just complete the see semiconductor laser, how the semiconductor laser works.
It's a crystal very much like gallium arsenide, tiny crystal with mirrors front and back, polished or cleaved, so it is a largely reflecting surface on both faces. And you pass a current through the diode that populates the space inside the junction with electrons and holes. And these recombine and produce light, which is bounced back and forth through between the mirrors, and that inspires more electrons and holes to recombine and singles out, instead of a broad beam of spectrum of light, it concentrates at a single frequency, and all the light comes out in a very intense collimated beam.
Yes, now we'll just discuss about the application of laser.
In this video, I'm going to be talking to you guys about some of the practical, real-world uses for lasers. I'm going to be doing 15 uses for lasers, and this video is mostly in response to a lot of comments that I get on my laser videos saying things like, what do you use lasers for lasers? So I wanted to kind of do a nice little compilation video to kind of explain some of the real-world uses that people are using lasers for today in different industries. This list is definitely not all inclusive. There's a bunch more laser uses that I was not able to include on this. I just included 15 that I thought were pretty interesting and that some of you might not have heard of. And it's in no particular order besides number 1, just because number 1's kind of my personal favorite. And that is laser photogrammetry, and I'm hoping I'm pronouncing that correctly. And it's basically a method to measure large animals underwater without having to physically take them out of the water or hold a long, say, rope or measuring device up along the side of them, hoping they hold still. This method involves mounting 2 lasers basically on parallel lines, and it involves a lot of precision and a lot of tweaking to make sure these lasers are on precise parallel lines so that the dots would say be maybe 1 foot apart from each other at all distances, or at least within a couple hundred feet. You would then aim the 2 dots at the side of an animal, say this whale shark, and take a picture of the entire animal with the 2 dots on it, and you can then look at that picture and say these 2 dots are a foot apart, how many of those little spacings can we fit on this one picture right here, and that'll give you a pretty accurate size of the length of the animal, a lot better than just eyeballing it. Lasers also have a big place in astronomy. The images that you're seeing right here of these yellow lasers coming out of observatories, these are sodium lasers which are being used to create guide stars, basically doing a reverse distorting of the atmosphere so they can get a clear picture of what's beyond our atmosphere. However, the process is a lot more complex than that short little summary I just gave you. Lasers are also used on the satellites that scan Mars and the topographical maps they create of Mars. Lasers are used on board those satellites, and we obviously also use lasers for stargazing and for pointing out different constellations in the sky. Use number 3 is laser levels, and these type of construction tools will allow you to generate laser lines on walls or surfaces to create a more accurate level, get perfect 90-degree angles, and other construction purposes with absolutely perfect lines that you wouldn't otherwise be able to get. Use number 4 is the medical field, where lasers are used for a wide variety of things, including LASIK surgery, dentistry. They're widely used in tattoo removal. You see them used a lot in MRIs and different types of scanners, and they're also widely used in skincare. Lasers of different wavelengths have a lot of uses in the medical field. The 5th use is data transfer and communication via fiber optic cables. So the concept, I'm going to simplify it as much as I can here. Imagine you have a cable, a wire that is hollow on the inside, and all the walls on the inside are very reflective, like a mirror. If you were to shoot a laser into this wire, the laser beam would just keep bouncing off the inner walls of the wire, and it would come out the other side. It wouldn't just stop inside of the laser if there was a turn. It would just keep bouncing and following the wire until it came out the other side. And we are using these laser lights to send information and communicate, and that communication is now being sent at the speed of light, much faster than previous ways of transferring data. Now, it's obviously a lot more complex than that, but that's just a very simplified version. Number 6 is going to be laser tag, and this one's pretty simple and straightforward. I'm sure most of you have played it in the past. Just involves using lasers to shoot at targets on your enemies. Usually they'll be wearing some type of a vest with a target on the shoulders, back, and chest. If you hit those little targets, the enemy will be disabled for a couple of seconds, and you'll get a point or 2. Use number 7 is materials processing, and this is just kind of a blanket term I use for the different uses of manipulating material with lasers. This can be engraving, this can be lasers used for drilling, lasers used for cutting items like metal. There's also lasers used for removing rust, and there's also lasers used for welding. Now, the lasers used for all of these uses are typically in the invisible spectrums and also very, very high powered and would burn your skin immediately. And that leads me to number 8, which is military uses. The military has actually for some time been working lasers into their weaponry, using laser systems to shoot down drones, shoot down planes, and shoot down missiles. And they've began mounting them on ships, on trucks, on planes, and these lasers are also very high powered and have the ability to go straight through metal. Use number 9 is one of the more obvious and conventional ones that's been around for a while, and that is the use of laser diodes in disk drives to read DVDs and CDs inside of your DVD player or your Xbox or whatever it might be. Inside of any of those devices that take discs, there will be a little diode with a little laser that is being used to read that disc. Use number 10 is in...
Yes, now you can you can just see that there are numerous number of applications of the lasers. So now we'll end today's class, and tomorrow's class we'll just discuss about the optical fiber. The chapter number 1 is completed. Thank you everyone. Thank you for your patience.